Okay, so let's look at practice B. So first we're going to look at the first part where it says real images from a concave mirror. So let's look at the first problem. So again, we're going to write our given and find. And we'll look at the first problem, and that's that. So we're going to write our given. So an object 3 centimeters high, so that's the height of the object, which is HO, is 10 centimeters in front of a spherical concave mirror. So the distance from the mirror to the object is 10 centimeters. And having a radius of 12 centimeters. So the radius of curvature, or the center of curvature, is 12 centimeters. But what we have to know is that the focal length is the radius of curvature divided by 2. So 12 divided by 2 is 6 centimeters. So then the question says locate the image. So locating the image means finding the distance of where the image is. B, what is the height of the image? So that is HI. So our basic equation is 1 over F is equal to 1 over DI plus 1 over DO. But we want to solve for DI. So that means we want to rearrange the equation to solve the unknown in terms of the known. So if we were to do basic algebra, okay, we could rearrange that. So when you rearrange it, you always put your unknown on one side of the equal sign. So what we would do is say 1 over F minus 1 over DO is equal to 1 over DI. The common denominator would be FDO. So I would have DO over FDO minus F over FDO is equal to 1 over DI. Then I go ahead and subtract. So DO minus F over FDO is equal to 1 over DI. I cross multiply. So DI times DO minus F is equal to, and I'll just FDO or DOF, it's the same thing. So this is my unknown, so DI is equal to D subscript OF over DO minus F. And the reason I just change that multiplication because it'll be easier to remember. Now I go ahead and substitute in my values. So I have, and again, I didn't have to do it like that. I could have left it FDO. So it's going to be 10 centimeters times 6 centimeters divided by DO, which is 10, minus 6. So 10 times 6 is 60, divided by 4, and I can do that in my head, that DI is equal to 15 centimeters. For the next part, part B, now I'm going to use my equation, and it's kind of like hi-ho, di-do, so it's HI over HO is equal to negative DI over DO. I want to solve for HI, so again, I'm going to just multiply. So I'm going to say HI is negative DI times HO over DO. So then I'll go ahead and say it's negative DI, which would be 15, times HO, which would be 3, divided by DO, which is 10. So 15 times 3 is 45, divided by 10. So this is going to be negative 4.5. So again, the height of the image, when I'm looking at my principal axis, positive is upright and negative is going to be inverted. All right, let's look at the next set. So it's virtual images from Concave, and what we'll do is we'll do the first problem there as well. All right. So when we look at this problem, it says we're going to write our given and find. An object is 4 centimeters in front, so that means the distance of the object is 4 centimeters in front of a spherical concave mirror of 12 centimeter radius. So if this is 12 centimeters, and I can call this R, sometimes people call it C for the center of curvature, but that means that the focal length is half that, so that's going to be 6. Locate the image. So that means I want to find DI. So again, our basic equation is 1 over F is equal to 1 over DI plus 1 over DO. And now I want to solve for DI. So again, I can just use what I did before and say DI is DOF over DO minus F. It's easier to remember that way. So it's going to be 4 times 6 divided by 4 minus 6. So when I do this, 4 times 6 is 24. What we're going to end up with is a negative value. So DI ends up being negative 12. And because of our frame of reference, the distance of the image, again, if we're looking at a concave mirror, again, it has to tell us, is it in front or behind? That's what the negative sign tells us.